Okay, then we will start. I think this is today we are having the second session. I think you have got the resources. I think there are several new participants. I have emailed them my last time recording. Then if you miss anything about basic, how to draw the model and the things we discuss, ABC, then you can refer to that particular recording of our session 1. And this is the second session number 2. And I have sent you some resources as well. I think last time I gave you this conceptual framework as an exercise. Today we will further work on this one. In addition, I sent you several reading also. You can remember 2 PDF documents where the basic things about PLS, why PLS, and comparing PLS with other SCM techniques. All these things you can find some of the seminal works, including Ringel. And here they are the founders of this Smart PLS software package. Therefore, when we talk about the SCM, structural equation modeling, this is one of the recommended package, but there are other packages as well. Especially you might have heard about SCM. Again, we get using AMOS package, but this is different from AMOS. You can see last time also I mentioned the basic differences. Sometimes some do for their PhD or research AMOS. Some use PLS, here is Smart PLS. But there are certain logics. Sometimes you might be using AMOS, but there should be a logic. In this case, the logic I mentioned that compared to AMOS, this is more user-friendly and very simple, but can be used for more complex modeling, as well as when you don't have the parametric assumptions fulfilled. Sometimes in AMOS, you can see minimum sample size should be 250 or above. If you don't have 250 or above, you can't do the research. But this is not like that. Even with a sample of 50, you can start doing the research. This is more practical. Sometimes we say that in statistical analysis, in the Viva, they ask about the parametric assumptions, right? The panel. Sometimes they ask whether you have the normal distribution. That's a key concern. We call parametric assumptions. There are a set of parametric assumptions. One is this normality. In this case, normality is not a must. Therefore, that is relaxed. But if you look at AMOS, there are a lot of restrictions. Therefore, now this Smart PLS is getting more popular because of the practicality, the application, and the simplicity. But you can do this for a lot of complicated data analysis as well. But remember, this is for the conceptual framework-based research. Let's say you are doing a research survey methodology. You are having a conceptual framework like this. Can you see the screen? Any feedback?
Yes.
Okay.
Yes.
Okay. Then you can see conceptual framework like this. Then if you have something like this based on your literature review, you have developed, then you are having a particular quantitative methodology, basically survey research strategy. Based on that, you develop the operationalization to measure each and every conceptual, what do you call, variables. Sometimes we say construct. These are not something like tangible things. That's why we say concepts, right? These are abstract concepts. Now you can see here reputation. In summary, I put the label reputation, repute. That is form of, again, 5 variables. We call dimensions. Then when you're doing your literature review, operationalization, to develop the questionnaire, you might have good idea. Then you should have that foundation knowledge in the survey strategy. Now my task is to how to elaborate that in the particular practical way to assess the model validity, and also the structure relationships of the model. That is the task of this session. Then today is the second session. Next week, we will have the third session for some advanced topics like one is multi-group analysis. Sometimes you can see the group-wise differences in the model. That is another important area, very popular area in Smart PLS and SCM. Next week, we will discuss that one. And also another thing called tetrad analysis. These are some of the additional things I'm going to discuss next week in third session. But today we will basically discuss again how to run the model and also how to develop the particular scale and how to see the validity and reliability. Last time also I elaborated, but further we will discuss today those things as a continuation of the last time one. Anyone who missed about the basic things, how to draw the model, you can refer to my recording, which was emailed last week. Then you should have this particular PDF document as the particular model we are going to discuss. And I have sent you database data set also. Anyone who missed that, they can get this. You can, I will record this one also and send you. Therefore, you can further refer this. Some people might not be attending because of the power issue. Therefore, they can get the recording. If you refer to last time recording, you can understand the basic things which I briefed and see whether you got this particular file also. That is about with my name. There is a particular Excel-like file. This is Excel format, but this is not the normal Excel. We call this is comma.csv format, right? CSV file. That is also a particular specific format of Excel, right? You know normal Excel worksheet. But this is particular version of Excel. We call this is comma.csv file. It's very famous as CSV. Comma separated, comma delimited. You can see this term. Therefore, remember when you are running PLS, you have to have your data set ultimately in this format. Last time also I mentioned. Anyone who missed last time, that's why I'm briefing these things repeatedly. Any clarification up to this point? There can be several new participants as well. Mr. Lasantha, any clarification? Are you clear about this?
Yes, I went through your video, so that was very clear, and I did the exercise by myself also just to get myself familiar with the software. Okay, thank you very much.
Okay, great. Thank you. Then I send you the link also to download that one, but I had instructed not to download the professional version. Since like if you download the professional version, you can go for 30 days. After that, you have to pay and buy the license. But the case is in your laptop, only once you can get this trial version of this professional one. Therefore, maybe if you are having like finance, you can make it, right? But if you don't have, right, if you cannot afford this, you can try student version, which I email you how to download student version also. I'm working on that one. That is lifetime free, right? Student version. But there are some limitations of the student version. Now, when you download that one, you can see on your desktop, you can double click, then you can open the particular PLS software, right? You can see the graphical interface. Now here I have several projects open, but when you do this first time, you don't have any projects here. Therefore, you can go to here, file, and you can create a new project. You can save that by particular name of your research or the thesis or your project. That's the thing. When you open that, you see here I have several 6 or 7 projects I have saved. First, you have to do that. Before you get any data, you have to open a project. Now you can see for this one, I put SAB Sabaragamua. Then this is the project which I opened last time. Then you can double click that. When you double click that, you can see there are 2 things here. I open data set. I imported particular data set. That's why here the particular 95 cases. In that one, I had what you call this specific format of Excel, comma.csv that had 95 cases. I email you that particular data sheet. There are only 95 cases, mean 95 is a sample size in that case, right? That's why it's 95. Therefore, you can see that in this format. But if you're having any errors or anything in your data set, it might not be like this, right? Sometimes it can be red and there can be error mark. But when you're having the error-free data set, you can have this green color one, the perfect one. That's the thing. When you double click this one, you can see your data set. Here you can see the indicators. Particular operationalization you do for the survey, you know indicators, right? Indicators make particular unseen, unobservable, larger variable of the construct. Now here you can see loyal 1, loyal 2, loyal 3. That is something about loyalty. Loyalty is a concept which cannot be seen directly as one holistic thing. In that case, we have to use the multiple indicators. That's why loyalty we measure using several what do you call elements, indicators, questions in a questionnaire, right? In the social research, that's the nature of this, what do you call construct. Construct are really what do you call unobservable, right? Those are abstract, not concrete. That's why we had to use multiple items. Now you can see here there are 3 items. Then if you look at something like AMOS, like you need minimum 3 indicators for a particular construct or variable. But in PLS, even using 1 indicator, you can develop a particular construct or variable. Therefore, there are a lot of flexibilities in Smart PLS compared to some other packages. Then you can see the indicators, and also you can see a summary of your data set. Right? It's nicely shown here. You can see any missing values are there. Mean value of each indicator you can see that is automatically coming as a summary. Median, minimum value, maximum value. These are something you can see at a glance. Whether your data set is good or having some issues, then you can see at a glance before you run the model. If you're having any issues here, you can treat them before you draw the model and run the model. That's why this part is very important. Then standard deviation, whether you are having what do you call this normality or not, even you can see that, right? Skewness, kurtosis, those things also you can see there. Here further you can see indicator correlations, but at the moment we don't need these, but you can see at a glance on the data set some summaries. But when you click the raw file, you can see your original data set, right? But that is not properly shown here, but you can see here data set, that condensed form you can see here. Now this is the particular data set you have imported as a comma.csv file. Usually when you click this one, you can right click. Now in this project, there you can import the data set. In addition to this one, if you want, you can import another data set where you want to do later some of the analysis under the same project. You might have saved this somewhere in your computer. Therefore, you can simply import any data file here. Now I have imported this one, therefore no need to import that one. But if you are doing first time, you have to import that here. Then here you can see second one. This is a particular model, path diagram model, which I developed last time. But first time when you open this one, first you have to import the data set. Then you have to here click this one, right click. Then you can have this path model. You can see create a new path model, create a new project. Now you have created the project, imported the data file. Here, create new path model. If I click this one, you can create, I can create another one, right? That means you can create more than one if you want. Okay. Then you can see I created second one also. When you double click that one, you can see this canvas on your right hand side. Now there is no particular model here. You have to draw on this canvas. Last time we discussed up to that point. And for the moment, I don't need this one. Therefore, I select this one and I delete. Then this is the one which I developed last time. You can double click this one. Then you can see the particular model which I developed last time. Now, this is the particular model I have in my mind. We call the conceptual model. It's a particular mind model you have. This is based on your literature review. Maybe in your research proposal, you have the research problem, objectives, literature. Based on literature, you derive the particular conceptual framework. You identify the concepts and the what do you call the relationships. Using the arrows, you link them. That's a conceptual framework which you developed. Now, if you are doing a survey approach, you can see up to this point, you are there. Then The other part is develop the operationalization and collect the data using the questionnaire with a representative sample. Then you need that part also. Then you need Smart PLS to run the model and test the hypothesis. That's the purpose of having this package. Now here, remember in PLS, yes, Mr. Lasante, yes, any clarification you can ask, I think. It's okay.
I have a question.
Yes.
If you just go back to your model, please.
Okay.
Now here, now we have the latent construct repute, and then you have the indicators, sorry, the dimensions.
Yes, yes.
Now these are reflective.
These are reflective, correct.
Yeah. Now what happens if the dimensions are formative?
That is possible. That is coming with your literature review. That means when you read now, if you look at this conceptual framework, I had drawn those, for example, based on literature, we will assume as the reflective dimensions.
Yes.
But you mean it arrows can be headed towards a reputation or the main construct. Then it is formative. That is also possible.
How do you change it here?
Okay, it's
I tried it, it's not allowing.
this one you have to simply draw like this. Select.
I suppose
select.
at the point of
You have
drawing.
to draw the connector. You have to get.
Right.
Very simple.
Okay. I understand. Right. Okay.
I will do that. Delete.
Okay.
Then you can select the connector. Then you have to start from this place to this place.
Right.
That's the way you do it.
Right. Okay. Thank you. Thank you very much.
Okay. If you want, you can redo here, right? Undo, redo, those things are there. You can simply try this. But if you want to have the model indicators, formative reflective, simply you have to click on the particular circle, dimensions of the construct. Then you can do something, switch between formative reflective.
Right.
You know that one, Mr. Lasanta?
Yes. Thank you.
Any clarification you can ask, that is more interesting, I think, rather than I did one way. Then we developed this model also last time, and I mentioned how to develop the moderating effect also. Today also I mentioned moderation as well as more important mediation also. Then I'm not going to draw the model again, but you can do something like this. If you want to develop a particular construct rather than a model testing, sometimes we develop the tool first, instrument. In that case, one instrument even you can test using this one. Now I delete these things. Now it's like this. You can see my conceptual framework. Forget about these three constructs: satisfaction, loyalty, and the price. These are the construct. This is also construct. You can see this one as the independent construct, reputation, but reputation is made up of 5 dimensions of the variables. You can see there. Now, rather than testing the model, some researchers or at your initial level, sometimes you want to develop the model, particular, not the model, construct, right? Construct means this part. Reputation, how the reputation is measured, and look at particular scale to develop the reputation. That is also can be one objective of some research. Therefore, in that case, I can remove these things and I can only develop the model, not the model, this particular construct like a model, submodel. This part I can test. How? Normal way you can do it. Now this part simply I can go to calculate. Now this is a, you can see some dimensions, you can see these are formative or reflective. You can see leader, corporate social responsibility, governance, finance. These variables are formative or reflective. Any comment? Last time also I mentioned formative, reflective. Yes, leadership. These four are formative or reflective.
Formative.
Formative, yes. But here quality is reflective. You can see last time also I mentioned. But traditionally, this is coming from literature. When you're having a rigorous literature review about how they have measured in the past research and the argument, you can say whether this is formative or reflective. But sometimes, let's say you develop a new particular construct. In that case, sometimes no literature available. In that case, PLS gives you the opportunity to identify whether this is formative or reflective. Next time, we will discuss that using tetrad analysis. That's an advanced topic. Next time, we will discuss. But for the moment, we will assume this one also reflective. Therefore, I can go to switch between. Yes. Now, this is the one. Now, if you want, you can simply test this particular construct only, since this is made up of 5 dimensions. Now, my concern is about not looking at any relationship between independent dependent, which I deleted in the model. I want to have a good model to measure the reputation. Assume that reputation is having these indicators. And last time I mentioned, this is the repeated indicator approach. Why? I have hidden here all these indicators forming this latent construct. If you want, you can see that. Show the indicators of selected construct. You can see here. Last time I mentioned that also. We call repeated indicator approach. Why I am saying so? Reputation is made up of 5 dimensions or the variables. Then each dimension is having several indicators. But when you want to have the particular full model relevant to reputation, all these indicators again you have repeated here. Unless you repeat them, you can't see the complete model. Now, if I delete these things, you can see what happens. Because this is a repeated indicator approach. Last time also I mentioned, but anyone who missed that one, they can again get the idea. Now look at when you delete all these things, what happens? This reputation construct circle turns red. That means model is not active. Now you can see this one. Then if you are testing a particular construct, developing construct, again, repeated indicator approach you had to use. That means all these indicators, measuring these sub-construct or the dimensions or the variables, again, you have to drag onto the larger construct. Ultimately, you are measuring. Here the reputation. That's why, again, I had to drag them into the reputation one. With the shift, you can select all these and you can drag. You can hold them and drag. Then all it's turn blue color. That means now this is something complete. You can run the analysis. This total model you can see at the indicator level is reflective. Why? The arrows are headed towards the indicator. No? You can see arrow headed are towards the indicator. That is going from the particular latent variable or the construct. Even this one and also these dimensions also. But if you want, you can change the direction. But there should be a what do you call the particular theoretical logic behind that. That's why literature is very important, whether these are formative or reflective. But again, I want to highlight, if you look at AMOS slide, you can have only reflective sort of indicators. Your model is reflective, simply in AMOS. But in PLS, there is another advantage. You can have several these dimensions or construct reflective, but others can be in the same model formative. Now I can have the leadership as formative, but others can be reflective. Even that is also allowed in this PLS. But in AMOS, you don't have that sort of flexibility. Therefore, there are some advantages when you have this one. Sometimes we might be measuring leadership as a formative construct, not as a reflective one. I think last time I mentioned what is formative, what is reflective. Like you should have a strong logic. Now, when the leadership is there, you can see here, no? Now these are formative, no? Quality, corporate social responsibility, governance, finance, these are formative. But this one is reflective. You know, leadership is the only one which is reflective. Why? These are arrow-headed towards the indicator. Then how can you understand formative reflective? Any idea?
From the direction of the arrow?
Yes, but what's the logic? Like why?
I think formative, my understanding is that, all those indicators are important for that dimension to be measured.
Correct. Correct. Very simple logic is, first, indicators are happening if you're having a formative one. The result is the particular latent variable of the construct. That means first condition is to happening the several indicators. The result would be the particular outcome. But if you look at, there are certain scenarios where, let's say, service quality or something, for example, when the service quality is there, after that, there are certain results are happening as indicators. Then it's like this formative. Here, leadership, you can see. When the leadership is there, because of the leaders, certain qualities, certain things are reflected after that. That means first happening this leadership quality, the broader leadership. After that, its resultant would be the indicators. That's why we say this is a reflective one, right? This is a reflective one. But if you look at these formative ones, you can see first the indicator is happening. Very simple example, you can see literature to explain this. If you look at the person's stress level, the stress level we can measure in different ways. Some may be formative, some may be reflective. But we are measuring stress level sometimes using these indicators like persons maybe divorce. That's one indicator, for example. Then experiencing some maybe met with an accident. Because of these things, stress level later change. That means first this let's say accident happen, divorce happen, job loss happen. These things happen. As a result of these things, the ultimate outcome can vary as a result of the first few things. Therefore, we call that as a formative construct in that case. But if you look at service quality or something, because of the quality is there, sometimes online ordering is taken, food quality is there, and also responsiveness is there. That means after happening, the broader service quality, what you call the construct, as a result of that, these indicators are reflected. That's why we say that's a reflective one. That's how you are trying to understand. That means always you have to look at from the literature this thing. But there is another approach. Next week we will discuss tetrad analysis, whereby you can know for a new one, new construct you develop. You don't know whether latent variable is formed as formative or reflective. In that case, you can check whether using the simple correlation based analysis. Next time we can discuss that. Therefore, this is a particular new area formative construct. If you look at the AMOS, you can't find this one. That's why I just want to highlight formative and the reflective. For the moment, we are having all these as formative. Then these things also you can have formative. But the case is sometimes you can run the model and see what's the best one. Now I will run this. We will see. This is sort of trial and error approach is there. You can try and see whether your results are coming better or not. What do you call in this one measurement model we have to first look at. First, I will go to Pls algorithm. And remember, in PLS also there are several things. One is Pls algorithm. But here when you go to consistent PLS, again you can see consistent algorithm. then there's a difference. Last time I mentioned that one. Consistent is there when you have reflective sort of what you call the construct. But when you are having formative ones, we are having normal regular algorithm. Remember that when PLS was first developed, they had only formative ones, not the reflective ones at the beginning. Therefore, they had only regular one we call normal PLS algorithm. But later, PLS also had reflective ones, sometimes a mixture, some are formative, some are reflective. In that case, they introduced consistent PLS algorithm and also consistent boost tracking. Now, in this one, I will go to PLS algorithm. I will assume this is a formative one full model PLS algorithm. Then here, there are several things, but here I go to factor, not the path. If you are running the final model for testing hypotheses, in your model, you can go to path. But here my thing is not to test the path, but to measure the particular construct and develop the construct. I selected only one part, reputation, not the full model. Therefore, I go to factor here, factor. Then I start calculation. Now you can see here, certain results are there, reports are there. But when you go to diagram also, particular map, graph, you can see the particular model with their path values. And what you call, these are sort of the path values, we say that. Like the contribution beta coefficient in a normal regression, when you run SPSS, like you can see how each dimension is contributing to the overall one. You can see, but this is as a format, you can see as a formative one, no? It's a formative model. Now you can see here how each dimension contribute to the overall one. Now we go to PLS algorithm reports. You can see the reports here. When you go to reports again, you can see the path coefficients, which I saw in the particular diagram also, you can remember. These things again, you can see in the reports also, but there's a comprehensive report here. What you want can be copy pasted or can be exported into your reports. Path coefficients, you can see here, how reputation is contributed by each and every dimension. You can see indirect effects and the total effects are not important here. Later we will discuss on the mediation, those things. Then outer loadings you can see here. These are the outer loadings you can see on the model. We call outer loadings. Outer weights. Usually in the formative model, you are having the outer weights. Remember that. It's a formative model. Therefore, you can see the outer weights, not the loadings here. Since this model is a formative one. Therefore, these are the outer weights. Outer weights. You can see here the outer weights. Then discriminant validity, construct reliability and validity, those things are also there. These are very important when you develop the particular model or the particular tool or the construct. Now here, important thing is looking at the average variance extracted. Now in this model for this hypothetical data set, red color, but red color means it is not good. That means you have to clean the model. That means sometimes this model also might not be correctly developed since this is a formative one. In that case, sometimes you can try this as a reflective one and see the results. That's how you are trying to sometimes develop the best model. That's why you have to do some trial and error and see how it emerge. Now in this one, some of the values are also minus. That means this is not a good formative model. In that case, I can try having what do you call this reflective model. Maybe this is developed for reflective. In that case, there are very abnormal outer weights in this model. That means sort of indicator that this is not a particular formative model. That way you can try initially your particular, maybe the tool development. That easily you can do this. Again, I can change these things as a reflective model. Actually, this is developed as a reflective model. That's why there were very abnormal values and the minus values for the, what do you call this, outer loadings or the outer weights. Therefore, you have the complete freedom to try these things. Now I run. Now I am not running PLS algorithm. Why? Any logic? I mentioned that one. Now I am going to consistent PLS algorithm. What's the logic which I mentioned?
That was the older version, which was done for formative measures only.
Yes, yes. When the model is formative, fully formative, you can go to normal regular algorithm and the bootstrapping. But now I am having this fully reflective one. No, you can see that means arrows are headed towards the indicators, which I measured these questions. Therefore, I go to consistent one and go to consistent PLS algorithm. Now the same process. Yeah, I go to partial least squares and I select factor again, not the path. Path you have to select when you run the final model to test the hypothesis. We call the inner model. Still, I am developing the particular construct here, right? Only one part, not the full model here. That's why I go to factor. We are doing a simply factor analysis here. You have heard about factor analysis. I go to start calculation. First, you can go to the model, reports are generated. Now you can see here, these values are much better. That means originally this was developed through literature as a reflective model. That's earlier we had a lot of abnormal values at the formative model with the weights, outer weights. Now these are not the outer weights. We call these are outer loadings. Why I am saying outer loadings? Since this is a reflective model, you don't have the weights. You are having the what do you call loadings, like the correlation like loadings. But weights means simply standard regression coefficients, right? From each indicator to the dimension or the variable. Now, usually the particular value we are looking in PLS for these indicators to be acceptable, it should be 0.7. Remember 0.7. But sometimes we allow 0.6 also. 0.6 also. We need minimum 0.7. That's a threshold level. Now you can see here these dimensions and they are particular reflective indicators. They are having a lot of agreeable level, 0.7 and above. Here you can see one is 0.671, another one 0.624. But sometimes you can argue and you can keep. Don't let statistic decide everything. Sometimes in your literature, if you find this particular indicator is a very strong one in the past research also they have used, sometimes you can keep this. Likewise, you can argue. Don't let PLS remove everything, right? By looking at the numbers and the values. But sometimes you can decide. Now here, look at it's 0.55. That you can delete. How you are going to improve the model? Now you have to go to algorithm, the reports. You have to go to construct reliability and validity. That is very important when you develop a particular tool or when you look at the outer model, right? Validity and the reliability. Here I go to average variance extracted. You can see here, average variance extracted. See, as a graph also you can see for each dimension and also for the overall one also reputation is somewhat less. It should be minimum. Average variance extracted is the reflection of the convergence validity. Remember, convergence validity. Convergence validity means the particular concept you measure all the dimensions converge with that overall construct, convergence validity, right? How all together these 5 construct form the particular reputation construct. We call convergence validity, converge, that align with, all together that form the large unseen unobservable construct. It should be 0.5, but if you look at dimension level, these are really acceptable, no? 0.5 and above AVE. But sometimes you can see the overall one, it's less than 0.5. In that case, you can do some improvements. That's why I mentioned, look at that one and try to improve that. That's how you use PLS to improve the model, right? Now, if you want, you can delete here finance 2 and you can rerun the model. And again, you can go to reports and see whether your overall AVE is improved or not. We will try and see. Finance 2, I will delete since it's having low factor loadings, 0.5 something, but we need 0.7 and above. And remember, if you delete this one here, don't forget to delete that one in this repeated indicator approach in the larger construct also. Here, finance 2 is having again very poor one, no? 0.031, very, very low value. Therefore, I delete that one. And also here also I delete that one. It's a repeated one, no? If you delete in one dimension, in the overall construct also you have to delete that. Now I run the model again. You can do that fast. I go to consistent. By default, this factor selected. Now you can see the model. Finance 2 is not there. Financial performance. I go to reports. You can see the new report here. You can see the construct reliability and validity. First, I go to average variance extracted. Now you can see a little bit improved. What about your guess? How can you improve that further? At least minimum level. Any guesses? Now I mentioned how to do it. Now you can see here, no, this governance also very poor. That means less than 0.7. Anyway, your target should be 0.5 for the AVE for the overall construct, average variance extracted. That's a part of the convergence validity. That is very critical. Yes, Mr. Lasantha.
So does it mean that you go one by one, or if you look at all the data and then remove the indicator where the factor loading is less than the threshold level?
In one time you can do all this. At once you can do it.
Okay. Well, what is the better way of doing it? One by one?
One by one means now in this model, if I see very poor ones, all you can remove.
Okay.
Yes.
Right.
So level is for the factor loading should be 0.7 according to literature, 0.7.
Right.
Then if you see maybe first you can see even 0.6 something you can keep, but if you see several one less than 0.6, all you can delete in the model and run the one.
Okay. Right. Thank you. Thank you very much.
Yeah, you can see governance 2 is like having a sort of a low factor loading. Then governance 2, here also you can see that is also very low. Then you can remove that. But if you find another one also here, if you want, you can delete this one also. But if you want, you can keep that one. Sometimes maybe here only 2 indicators are there, but even in PLS, you can have only 1 indicator. That is also possible. But in AMOS, you need at least 3 indicators per construct. Unless you don't have 3, you can't run it. That's the case. Now I remove governance 2. Here also I remove governance 2. I go to consistent, right? Since this is a reflective one. I run the model. construct reliability and validity. First, I go to average variance extracted. Then I see it's very close, but not yet. And remember, now I started with that one, but in addition to that, look at these two also, right? Convergence alpha, that is acceptable. No, 0.7, no threshold level. You know, in literature also they talk about 0.7. It's the minimum level for the Cronbach alpha for the reliability. In addition, Cronbach alpha, there's a better reliability coefficient, composite one. They look at rather than single one, composite one, overall model and how it fit using the correlation matrix. We call the composite reliability. This is much useful than the Cronbach one. You can see here, these things are also there at the acceptable level. That means your model is really reliable. Particular dimensions and the overall reputation also you can see it's there. Then average variance is a problem here. But remember, you delete so many items less than 0.6 or 7, still you find this reputation. Like this red color, that means less than 0.5 AVE. What should be your decision? Now, practically, we have such issues. Sometimes you can't find everything as you want, right? You can't find everything as a 0.5 and above. Sometimes practically in research, there can be such issues. You delete, but after that you can't delete. You are having all the items fulfill these 0.5 and above. Then still reputation may be sometimes red one, that means less than 0.5. But close, but you have improved sufficiently, but it's still somewhat less than 0.5. What should be your practical decision as a researcher? How can you do the research? Yes, any volunteer?
Can we try by removing or, in alterations, different dimensions?
Can you explain what you mentioned? Like,
let's say, we take finance out together and then run the model to see how it looks.
That also can be possible one. Yes. And the other thing is, you can keep this thing as it is. Why? You are having average variance extracted only less than 0.5, but look at other things also together, right? Cronbach alpha and also composite reliability. Those are sufficiently fulfilled. No, in that case, you can argue to keep this one at this level, but that is not too low. No, it's close to 0.5. No, you can see now that the value also you can see Cronbach and the other values here in the reports. The values you can see here. The matrix you can see, right? Sorry, in the matrix you can see the values. Average when is extracted, you can see close to 0.5, but somewhat low than that value. But you can argue that your composite reliability, then Cronbach alpha, those are sufficiently good for this reputation one. In that case, you can keep that one. Sometimes there can be some tough situation in research. In that case, some practically you can argue and keep certain things, right? Sometimes if you delete particular dimension, that also can be sometimes problematic. Therefore, you can decide based on your common sense and the particular practical scenario, right? Likewise. And also, as Mr. Lasanta mentioned, sometimes if you don't have anything like the big difference is there, let's say 0.2 or 3, sometimes you can delete some dimensions and see. That is also possible. I have seen that in some research, they have removed the complete dimension, but we had to report that logically. Why it happened? Because of this, it happened. Something like that, you have to justify. Remember. Now I'm talking about some practical issues. We can easily run the model. That's a very maybe few seconds it takes. But these are the practical problems when you develop a particular construct. Now this is not the full model. This is a construct. But you have to measure this construct is valid and reliable. That's why I'm looking at a particular construct reliability here, convergence validity. But remember, in addition to that, there is another thing, discriminant validity. What is discriminant validity? Validity, basically, there are two things, construct validity. One is convergence. The other one in the construct validity, discriminant validity. What is discriminant validity? Now you can see here, correlation matrix. Any idea? What is discriminant validity? The meaning also very important, I think, right? With the meaning you have to understand. So some people might say discriminant validity, but they don't know the meaning. Any idea? Now convergence, I mentioned how all together these dimensions fit together to the overall construct. Support the overall construct. Align with that one. Converge with that one. Fit with that one. What is discriminant? We are looking at both in the outer model or when you develop a particular tool. What's the meaning of discriminant? Any idea? Discriminant validity. Discriminant means you need convergence at the same time. That particular dimension should not be 100% similar to the larger construct or the other construct you are going to measure. Not only between construct and the dimensions, between dimensions as well, you have to look at this. If you are having the same two dimensions with the same maybe the meaning, it is not the discriminant. That means two dimensions or the two concepts should be sufficiently different, significantly different, not the same thing. If both are the same, it's useless, no? Then your model also can be problematic, right? There can be redundancy. Now, simple example, love and affection. Love is a different concept. Affection is a different concept. Very simple example, right? But love and affections are having common properties as well. But love is significantly different from affection. But affection and love are having some common properties as well, right? That is also there. Likewise, you have to say whether your concepts are different from each other, not the same concept. Now, for example, I will explain sometimes maybe the quality and the, let's say here, I don't have anything to explain. Sometimes some data set, we are having very similar concepts. Sometimes the customer satisfaction and customer loyalty, they are very much related. Sometimes when you measure the loyalty, certain satisfaction elements also might be there. But it's still theoretically, satisfaction and the loyalty are two different concepts. Therefore, you have to establish discriminant validity also. Then only your model is a good model. If not, you can see sometimes issues like VIF issue. We call, what do you call this? Multi-collinearity, you know. Multi-collinearity issue is there. Here you can see that one also. Collinearity statistic is there, VIF factor, variance inflation factor is there, right? When two independent variables are highly correlated, that problem might be there. That is something linked to this discriminant validity also. Therefore, you have to establish that one also, remember. These are some of the initial things in the model you have to be mindful about. Now, how can I establish this one? This is based on Fornell and Larker criteria, right? The two people based on their particular argument. Now we are practicing this as a criterion to look at this discriminant validity. Now this is a correlation matrix. You can see corporate social responsibility with finance. Correlation is there. Corporate social responsibility with governance, right? Correlation is there. Plus or minus you can see. But you can see on this diagonal, corporate social responsibility and corporate social responsibility, they together meet on this diagonal. There you are having not the correlation. What is that? Any idea? Anyone who is familiar with this one? Fornell-Larker criterion? I think Mr. Lasanta, any idea?
Sorry, no.
You are not familiar with this one, no?
No.
Okay, okay.
That is variance, no?
Sorry?
Variance.
Variance. Yes, you came closer. Can you bit explain which variance? In this diagonal, you have the AVE. Can you remember which I mentioned earlier? Average variance extracted. Here, can you remember this? Average variance extracted. Look at this one. Corporate social responsibility. What's the AV value? Here, 0.959. If you go to this discriminant validity, this is the square root of that one, right? Square root of that one. Square root of AVE is on the diagonal, right? This is not the correlation. Now, corporate social responsibility and corporate social responsibility, the two same dimension, correlation should be 1, no? But this is not the correlation. This is the square root of AVE. AVE we discuss under construct validity, no? You can see there. If you test that one, you can find that one. Square root of this one is placed here in this, what do you call, discriminant validity under Fornell-Larker criteria. If you test that manually using a calculator, AB square root is this value for leadership. If you look at AVE for each variable, it's there. No? Now reputation, if you look at, if you want, you can cross-check that one, right? Yeah, but you can understand, right? You can be enlightened. What's the process? Now, what's the AVE of reputation? 0.482. When you go to discriminant validity, square root of 482 is this one. Just get the square root using a calculator. Then you can get this value. Are you clear up to this point on this matrix, how this value came? Is it clear, this particular grid matrix?
Yes.
Right. Then how can you see whether there is a discriminant validity or not? Can anyone tell me? Now I am comparing square root of AVE. Automatically this is coming, right? But in the previous versions of PLS, few years back, we had to manually develop this one. You have to get the correlation matrix. And on this diagonal, you have to manually calculate getting the square root. But now it's coming, right? Now this option is there in the latest versions. Look at corporate social responsibilities, AVE's square root with the correlation it has with other dimensions or the variables. If there is discriminant validity, the rule is, according to Fornell and Larker, their criterion, this diagonal value, that's the square root of AVE of the respective variable, it should be always above its correlation with other variables. Now, can you tell me corporate social responsibility is having discriminant validity with other concepts? What's your view? Now I am having on the diagonal square root of AVE 0.979, but correlation of corporate social responsibility with other dimensions or the variables here 312 minus 235 0.221 0.345 0.298. What's your view whether there is sufficient discriminant validity established or not for the corporate social responsibility? I mentioned the rule. What's the conclusion?
There is. No?
Yes, there is. Why? The reason is square root is of ABE. Corporate social responsibilities, ABE's square root is above than the correlations corporate social responsibility has with other variables of the dimension. Simply that's the case. You have to look at. Now here also that is established, right? But here you can see small difference, but still you can argue, right? Here it's established. But sometimes it is not established in some cases, no? Now here you can see quality and reputation. Then there can be some issues in your measurement, in your questionnaire items. That's why you have to do that model refining, right? By looking at the factor loadings and the things. You have to improve sufficiently, whereby you can try to minimize these errors. That's why pre-testing the questionnaire, having a very reliable maybe Pls validity and other what you call content validity in your questionnaire development, that is very critical. That's a homework. Even in developing the questionnaire, getting the right scale, that's you have to be very much careful in survey methodology. If you're having any issues there, sometimes these errors might be happening, right? That's why you have to sometimes back and forth exercise. That's why we go for a pilot test sometimes, right? You might go for a maybe a small sample, maybe 30, 40, 50 pilot one, and you can run PLS and see whether your model is having sufficient level of these qualities, validity and reliability. Whereby sometimes you can improve the questionnaire before you have the final maybe data collection, right? You have to be serious about questionnaire development also. If not, sometimes these issues might be happening. That's a discriminant validity. Hope you got the idea. Whether sufficiently discriminate, right, the other construct from the target construct, right? That means reputation is sufficiently different from other dimensions. And remember, recently PLS have incorporated another one, heterotrait, monotrait feature also. Remember, they argue that rather than Horner-Larker criterion, heterotrait, monotrait is much better one for this discriminant validity. Therefore, keep in your mind that this one also now people are reporting, right? Heterotrait, monotrait ratio. Therefore, using the literature also you can learn, right? Simply these things. But traditional one is a Horner-Larker criteria, right? Remember that. But when you further read on Smart PLS, Ringle, here, right? They talk about heterotrait, monotrait also. Just keep in your mind, right? The case is now these two are problematic, no? Why? You can see here sort of, this is not the correlation. This is based on the correlation. They do this calculation, heterotrait, monotrait. That is also based on the correlation matrix, right? The argument is this should be less than 0.9. This specific correlation should be less than 0.9. Then there is a there is less like issue, right? There is discriminant validity is there. Problem is less. But if you look at finance and reputation, this is above 0.9. Quality and reputation, this is about 0.9. Sometimes, again, in the data set indicators, there might have been some issues. In that case, again, you have to recheck. Sometimes some factor loadings might be problematic. Those factor loadings you have to remove. Maybe in quality or in reputation, sometimes those problems might be reflected there. Therefore, you have to manage this to a level less than 0.9. Then that is the second one in the validity. Now still we are talking about outer model. Last time also I mentioned, you can remember in the particular articles, in PLS or any SCM, there are two steps in reporting. There are two steps. I have sent you this particular article. Can anyone tell me the two steps in PLS or any SCM, how to report that in your analysis? Last time also I mentioned in one of my this shared article, you can find that one. There are two models we are talking about.
The outer model and the inner model.
Very good, very good. Outer model and inner model. Yapo, using that one only you can write report. Yapo, that gives you the structure, how to report that one. Now here there is some example about reflective and formative, right? How the same thing has been measured using formative and reflective. Now look at, sometimes cycling fitness of a person can be measured as a reflective one, but reflective indicators you need. Remember, like after, if you are having cycling fitness, after that only these are happening. These symptoms are there, right? Good heart rate, lactate level, muscle proportion. These are the things which are happening after this. That's why we say this is a reflective. But same construct can be measured using different one which are formative as well. When you are practicing properly, if you're having good training day to day, we can predict that you might be having good cycling fitness. Your nutrition level is good. That can be indicator that leads to cycling fitness. That means formative. First, these things are happening. Then we can predict that the larger unseen construct also happening, right? Drug abuse, that level might affect your cycling fitness. This is a formative one. Therefore, you can develop nice models, sometimes novel models using formative. Already in the literature, there can be reflective. But sometimes in new context, you can develop formative ones also. Next week, we'll discuss how to identify formative or reflective using the original data set. If there is no literature, past literature. Now, my point was to how to report this one. In one of the articles, you see this inner model and the outer model. Yes. First, we go to outer model. Outer model. We call the measurement model, another term, outer model or the measurement model. There we are looking at the reliability, validity. That's why I mentioned. So far, I talk about reliability, composite reliability, Convergence alpha. Then I talk about validity. Very important validity tools I talk about. One is about the AVE, Convergence Validity. And the other one, Discriminant Validity. This is very important, more reflective construct. Remember, reflective ones. You have to report this very importantly for reflective construct. And also, if your constructs are formative, still you have to report about this validity, not the reliability. Remember, when you read this article, you can understand further insights and the things about application of this PLS. Once you have established these things, you go for inner model assessment. Inner model assessment. Another term we call is structural model. Remember, outer model is measurement model. There are some indicators, validity and reliability. When this is passed, we go to next level, inner model. Inner model we call that's structural model, where we are having the path model, where we are having the hypothesis. We are interested in testing. That's our main name of the research. But before that, you have to do this external model assessment, outer model assessment. Remember, there are certain things. Effect size, we call F squared. Another one is there, predictive relevance. We call Q squared. And also path coefficient, and also this one, coefficient of determination. We call R square. In the inner model also, these three are very important. Before you test the hypothesis, you have to report these things as well in the inner model. And also there is now, what do you call, newly introduced one, STMR also. Later I will show you that one. Therefore, in this article, you can understand how to report PLS findings. Now we have completed basically our outer model or the measurement model. You can see. We look at the outer loadings. Loadings you can see here. I try to delete someone, right? You can see here those. If you want, you can hide this one in the larger construct. Sometimes it can be distracting. You have to mainly show these ones forming these dimensions. Now I have tested here a particular tool construct, but this is not my research. This is simply only one part of the reputation. If you are having a particular objective to measure, developing a good tool or the instrument to measure the reputation, you can do using only this part your research, one objective. But now my main task is to test the model. In that case, I had to go to the full model, which I had drawn earlier. And this is a full model. Now you can see I have reputation as one independent variable, then loyalty as a dependent variable. In addition, I have price as another independent variable, and also satisfaction. Now you can see in the conceptual framework also these things. Now this is our full model. But earlier I talked only about this reputation construct. That means this is a very complex construct. This is a higher order construct. Why I am saying this is a higher order construct? This is form of several dimensions. But if you look at here, price, satisfaction, loyalty, those are single order. But this is a higher order. Why? Reputation is formed by 5 dimensions. Therefore, that's a higher order construct. We call this a second order construct, right? Second order. Why? Before the reputation, we have to look at the dimensions forming it. These are the first orders. We call first order dimensions. First orders are making the largest second order dimension. So not dimension, we call the construct, right? Construct. The second order one or the higher order one. Sometimes you can see third order ones are also there in some research. That means these dimensions also form up several other dimensions. It can be more complicated in some research, some social research. But luckily we are having here only second order construct. But these are just single order. That means no dimension. Simply you are having only the indicators directly measuring from the question. Satisfaction, price, loyalty. Now this is a particular model I want to test. Last time also we discussed this one. Today further I will discuss how to test this one. Now just we finish this one. But when you are having a full model, ultimately you have to look at the full model testing, remember. But in my previous example, I talked to you about my one research objective is to develop this one. Maybe in that case, you can keep only these 5 dimensions and only reputation construct, removing these things. But when you come to your main research objectives and the main model, you need the full model, remember. Now I had drawn the full model. Now in the full model also, 2 steps you have to report. That means you have to go to this calculate. Now here we are having formative, but it should be reflective correctly, right? We found some issues when it was formative. This also I had to make reflective. I hide this. Okay. All these are reflective. Loyalty, satisfaction, single indicator I have. Pricing, two indicators I have. This one independent variable. This is a main dependent variable. In addition, there's a mediator. You can see the mediator. Why I am telling this a mediator? In my model through literature, I developed that one. You can see the set of hypotheses which I developed through literature. See, brand reputation significantly influences customer loyalty. Brand reputation significantly influences customer loyalty. You can see this arrow. That's the first hypothesis. Second one, brand reputation significantly influences customer satisfaction. That's the second hypothesis. Third one, pricing significantly influences customer satisfaction. You can see this main arrow from pricing to satisfaction. But remember, here there is another arrow, but this is a dotted line. No? Usually in SCM and in conceptualization, we use dotted arrows to show the moderation effect. In many research, you can see that as a no. But this moderation arrow is not headed towards any circle or any variable or the construct. That is directed towards the center of an arrow, no? That is directed towards an arrow, not to any variable or the circle. Why? It's a moderation. That means this relationship strength is changed by pricing. In addition, this is separate one also affecting satisfaction, right? That's a separate hypothesis. But you find in literature, reputation and satisfaction arrow, that relationship is further influenced by pricing. That means this effect is changed by pricing. Effect can be supporting or weakening this relationship. That's why we say it's a moderate, right? Moderate means particular variable here, pricing, that strengthen or weaken another relationship, not a variable, relationship. That means an arrow. That's why it's headed towards this arrow. That's why we say moderation. But when arrow is going to directly to a variable, that is not the moderation in the conceptualization. That is simply a direct effect. But this is an indirect effect as a moderate. Remember. Therefore, I developed the fourth hypothesis. Pricing significantly moderate the relationship between customer satisfaction and loyalty. But this is coming from the literature. In your model, you might have literature and develop this. Fifth one, customer satisfaction significantly influences customer loyalty. That is also you can see. Satisfaction, at this moment, satisfaction is independent, loyalty is dependent onto this relationship. Sixth one, customer satisfaction significantly mediate the relationship between brand reputation and customer loyalty. That is another interesting thing. Pricing was a moderator. That means arrow is going towards the arrow. That affect the relationship level, strength. But satisfaction is a mediator. Why? You can see this part. Through literature you have developed. Reputation directly affect loyalty. That is fine. We call that's a direct relationship. Direct effect. Later we will discuss in the analysis how to interpret that one. Direct relationship. Further, reputation affects satisfaction and satisfaction affect loyalty. That means there is an indirect relationship also. That's the case. Indirect. In addition to direct, indirect is also there. Yes, Mr. Lasantha.
This Professor, now this price impact on satisfaction. And normally we are taught there are antecedents, then there are mediators, there are moderators, independent and dependent variables.
Yes.
Now here, what is price here? What sort of a relationship are we talking about with satisfaction?
Yes, this is really a hypothesized model. First, I should tell that this is a hypothesized model. You need a strong literature backing to support this one. Now here, if I mention, but this is not my own model, right? I just adopted this one for the explanation.
Okay.
We can assume sort of a, let's say, price sometimes might maybe reasonable pricing, affordability of pricing in a particular market segment can have some influence on the customer satisfaction. On that assumption, this is developed, Mr. Lasant.
Because I'm having a video debate on my model, like something very similar.
Yes.
So I was initially told that you can't have two relationships like this. Is that right?
Two relationships.
Yeah, I mean, I'm talking about a moderating effect between the independent variable and the mediating variable. Yeah.
Now, for the moment, we will forget about mediation. We will talk only about reputation, satisfaction, and pricing. Moderation only as example. Okay. Please.
So that's clear to me. No, my question is, let's say, for example, price. If it has a relationship with reputation, just for discussion, right? Can it also have an impact? Can it, let's say it has a moderating effect, that I understand. But can this also have a relationship with the independent variable? If the theory supports
it can be, but not necessary for the moderation.
Okay.
If you read Baron and Kenny, I don't know whether you have read it.
Yeah.
Baron and Kenny's argument for a mediation moderation, you can read that article, 1986 article. Like for a moderation, there are several requirements. One thing is independent, dependent, there should be a relationship based on the literature. You should be able to argue. Now here that is there. No?
Yes.
Then the other thing is, it is not necessary independent variable having any relationship with the moderation variable. It is not necessary.
Okay.
It is not necessary. Then the other thing is reputation and pricing can be happening at the same time. But if you are happening reputation after that pricing, then sometimes this moderation might not be possible. Then it can lead to sometimes a mediator or something. In the mediator logic is after reputation, satisfaction is happening.
Yes.
That's the case. In that case, you can decide that's a mediation. But there is no mediation opportunity in the literature, very less, for moderation variable. That means reputation and pricing can be happening at the same time, but not after reputation, pricing is happening. It is not required at all.
Right. Okay.
Are you clear about that?
Yes. Thank you.
But anyway, this is a hypothesized model. Therefore, don't believe this relationship is strong, right? This is just for the discussion.
No,
only.
I have a similar situation. That's why.
Are you clear now?
Yes, but in my case, there's a slightly different debate. That's where I'm a little stuck now. I have developed the model, but it argues that it can also build a capacity inside the organization, while it can also moderate. So now that's why I'm stuck a little bit. I'm trying to figure out how it should.
Then you have much freedom in this PLS to take it out and run the model and see what's happening. That's a flexibility is there in Smart PLS, not like AMOS. Yes.
Okay.
Sometimes it can be. Yes, you mean
the time I can show you the model, then I can explain.
Okay, okay, okay.
Thank you.
Yes, next time we will discuss. If you
Okay.
email me, I will just have a look at.
Okay, okay. Thank you.
Okay, thank you. Then this is the situation. Now I'm looking at the moderation. Last time also I mentioned moderation. I will show you again how to run the moderation. Now the case in PLS, you can't draw the moderation directly. That's the case. Now, according to conceptual framework, if you want to draw the moderation according to the conceptualization, this arrow should be from this price to this arrow. That is the reputation and satisfaction linking arrow should be linked by the arrow going from pricing. But in PLS, you can't link arrow to an arrow. Therefore, we have to separately create moderation effect. How? Here there is an icon, no moderating effect. That is possible. Or else, calculate. You can see here. Not there. You can see. Here you have it, moderation. And here calculate, right? Calculate. It was here, but now it's not here. It's separately given, right? Anyway, moderating effect. Simply click that. Then you can see when you click that one, it's like this. Simply click the dependent variable. I deselect this one. Then I select, right click. Now you can see, right? Here you should find something about moderation. Yes, add moderating effect. That is possible. Or else using this icon also you can do the same thing. You have to click this icon and select dependent variable. The same thing is happening. That option is also available. If not, select satisfaction. Always dependent variable you have to select to create the moderation effect. Right click, add moderating effect. Now you get this dialog box. Now you have to select what's the moderating effect. You are having several variables now. Now what's the moderating effect? Price here. You select price. What's the independent variable? Reputation. You have to select that one. Now here there are several options. One is product indicator approach, two-stage approach, orthogonalization approach. This orthogonalization approach, we go for special situations. Two-stage approach also we go for some special situations. But by default, in the normal PLS, we go for product indicator approach. Remember, product indicator approach. I will explain what's product indicator approach. Only that thing you have to select, product indicator approach. In advanced settings, you don't have to do anything here. Normally they use standardized method, not the mean centroid or unstandardized method. They use standardized method. Here automatic by default is there, select, right, keep it as it is. Model A, model B, for some special situations only we do that. But now here we want to have the normal moderate effect we have to create. Click OK. Now we have created new variable. You can see that one. Now this is simply like this in your conceptual framework. In your conceptual framework, from pricing, there is a dotted line arrow going towards this arrow. That is the meaning of this created effect. But that is directed towards dependent variable. But the real picture is what you see in the conceptual framework, right? But this is the approach of PLS. Now you have created the moderated effect. You can right click and you can rename if you want, right? Moderating effect. If you want, you can create moderating effect of price or something. Or you can say reputation multiplied by price. This is the meaning simply. Reputation multiplied by pricing. Moderation means simply interaction. Interaction means multiplicative effect. Very simple idea. I will show you product indicator approach. Right click, show indicators. Can you see this one? Last time also, I think I discussed this one. So Lasantha, is it clear? Now you see this each indicator of the dependent variable multiplied by each indicator of the moderator variable.
Yes.
This is the idea of moderation really, technically. We call interaction effect also another term for moderation. That means we multiply each indicator of independent by each indicator of moderator and we create a new variable. That's why we look at when this new variable comes as a moderator, whether that affects together with that one, the overall relationship. That's the idea of interaction or the moderation. This is automatically created. This is a product indicator approach. That means each indicator multiplied product. You create a product of each indicator with independent and moderator. But I hide this one, it's very complicated. Now I have created that effect. Now you have to simply run the model. Calculate. Consistent, I go for Pls algorithm. You can do that. As usual. Now here factor is there. But if you have developed the model and tested the outer model before this thing, you can simply select here path. Now my target is not the outer model, not the external model or the measurement model, as I have tested validity and reliability. Remember. In that case, I select path. Path means now we are trying to test the inner model, structural model, test the hypothesis. But if you are not tested the outer model yet, select factor. That's a logic, right? Hope you understand. First I selected factor. Why? I haven't tested the overall model, external model, outer model. You have to do the same thing for overall model here. You can see here. Earlier I did this only for this construct, no, as a separate objective. But now I want to look at the full model, right? Now you can see here. Certain poor ones can be there. If those are there, you have to remove those. You have to look at other variables also. They are outer loadings or the factor loadings, we say that. When you look at single indicator, always it's one, right? The correlation, right? That's the nature. Then price, you can see this is very poor. In that case, you can decide to remove this one. Then it can be single indicator one after that. Sometimes that might happen. Then again, you have to go to the reports. Do the same thing which I mentioned earlier. Path coefficients. Before that, you have to go to these things, right? Sorry. Construct validity and reliability. You can look at the Convergence alpha. Price you can see, no, that is very poor. Therefore, in that case, better to have single indicator. That poor one you can remove. Then as a single indicator, that is happening. Now look at your satisfaction. When it's a single indicator, you can see always that is very good reliability level, right? By default, that's coming 1. Composite reliability also you can see. This moderation also very poor. Price also very poor. You can see that there. Then you can decide to remove some of the factor loadings of price, as I mentioned earlier, and try to improve that one. Then further look at AVE. Reputation also, as I mentioned, is still at a poor level, less than 0.5. These things you have to do in your research. But this is not a perfect data set. That's why these issues are there, right? I had a large data set. I deleted purposefully. The reason is that in PLS student version, you are allowed only 100 cases. That's why this, what do you call this, abnormal nature of some variable. I think you would understand the reason. But in your actual research, it is not an excuse. You have to do proper pilot testing and improvement of the questionnaire. Then you have to go for the mass scale data collection. Then you have to improve these things and see again, that's a construct reliability and validity. Discriminant validity also you have to look at. Fornell-Lark criterion, heterotrait, monotrait. You can see here there are a lot of issues. That means further you have to remove some indicators and try to improve this. Back and forth exercise you have to do. That's about outer model. Then I mentioned several things about inner model quality also. Can you remember in PLS article, PDF document, I talk about one thing about effect size. This is the one, F is square. Do you see that there? F is square. You can see it. This should not be 0 or minus. If it is 0 or minus, this red color you can see. Then there is a problem. That means each variable or the dimensions effect is substantial or not. That's the idea. F is square, right? It is not R is square, but that is also a particular quality indicator of the inner model. This should be above 0 plus value, but no need to be a very high value. It can be 0.1, 0.12, 0.2, 0.3 likewise. Usually we say that 0.1 to 0.3 like sort of a poor one. 0.3 to 1.5 to 0.3, we say it's a moderate one. Likewise, you can see F square interpretation in literature, right? I'm not going to explain that one. Always it should be sort of a plus value, but not a very high value. It can be 0.1, 0.2, 0.3 like. Accordingly, you can interpret that one. But in this model, there are some issues. Therefore, you have to correct that using deleting some indicators. Like you can try to improve that one. This is the effect size. That is for individual variable, right? That is also quality indicator of PLS model, inner model. Remember, you can see the values here in the matrix, right? These are -1. That's why red color. Then I mentioned another thing, R square, right? You know that one. I'm not going to explain R square, coefficient of determination. That is coming only for the dependent variables, right? Dependent variables. Here there are two dependent variables at a time. This is dependent. At a time, this is dependent, right? You can see. R square value. That is also a particular indicator of the goodness of the model. But if you look at AMOS, like they are having different indicators for their quality measurement, model fit. But in PLS, we are having different set of measurement. Remember, therefore you can't compare PLS model quality indicators with most of the ones in AMOS. And there is another one. If you go to here, model fit, there is another one. SRMR. This is latest one they have introduced for the model fit summary. SRMR is sort of error. Standardized root mean squared residuals. They say that in short. This should be less than 0.1. Then your model is good. There's a saturated model as well as estimated model. Remember, especially we are looking at for the saturated model, it should be less than 0.1. But here it's above 0.1. That means model quality is not acceptable. That means you have to delete some indicators and improve that one. If you improve those things, you would have come up with a good thing, which is less than 0.1. This is sort of an error. SRMR, residuals based analysis. SRMR, you have to report this one also. Some researchers now report this one also as a latest indicator of the model fit, right? Now, those are the things in the inner model quality. Mr. Lasantha, any idea or any concerns about this? Are you okay?
I'm fine, thank you.
Okay. Now only we have to look at the inner path. Now we have to look at the outer model. Where we look at the factor loadings, AVE, convergence validity, and also discriminant validity we look at. Now we assume we manage those things, removing some indicators, we improved AVE, discriminant validity as well. Then you come to inner model. In the inner model, you have to look at three things. One is FP square, the other one is SRMR, the other one is R square. And also I forgot another thing. You have to separately calculate that one. We call, that is, you can find here. Calculate. There's something called this blindfolding technique. Blindfolding. I will explain that one. This is also another model quality evaluation criteria in PLS, in a model. Here also you can decide whether it's a factor. If it's a final model, you can decide whether it's a path. I will go for factor since I'm looking at the model quality. Remember here, there's a stop criteria. This logic you can change. By default, it's 7. In some cases, you can improve. The logic is something like this. We call this test predictive relevance, like the predictive relevance. That means in your data set, according to this particular algorithm, they drop every 7th case. And they try to predict that value, missing value. They do that in the algorithm, right? You can decide. We call this a omission distance. Omission distance. Right? Omission distance. Every 7th item in the data set, they remove and they try to predict that missing value in the algorithm. Based on that, they calculate particular value we call Q squared. Not R squared, not F squared, Q squared. Now I run this. This is they run the algorithm, right? This is we call blindfolding procedure. It takes time, right? Sometimes based on your computer's capacity, it takes time and the data set and the complexity of the model. Now you can see here Q square value and also how it is calculated also you can see here, right? But as a researcher, you are to report this one, right? Q square value normally should be above 0, not a minus value, right? You can say 0.1 to 0.3, sort of a maybe acceptable level. 0.3 to 0.5 in between, you can say moderate level. 0.5 to 0.7, like you can say strong level of predictive relevance. That means your model is more relevant for prediction. You can see these values on the model also. Can you see? Now these are not R square. When you run the last analysis we ran was predictive relevance. That means this blindfold technique. Therefore, this is not R squared in this model here. Now you have, this is Q square, right? You can see here. Cross-validated redundancy, the concept. This is also coming for the dependent variable, like R squared, remember. But F squared is coming for each and every variable. That is for the effect size. As in individual variable, it's whether variable is significant or something, P square. But here they talk about predictive relevance. The data set, when several variables are omitted, whether they can predict that missing value, come close. That's a simple understanding, logic. Therefore, you have to report these things also under quality criteria of the model. That's blind folding. Then I come to my last step here. Pls algorithm, we ran the consistent one, right? Consistent algorithm because of the full reflective model. The algorithm we ran. Again, I will run that. You can run this any number of times, right? Again, I run it. You can have so many reports, right? That means when you run 10 times, 10 reports are there. But you have to look at the relevant report. Others you can remove. Now again, I get the reports. Now I go to the model. Now you can see here. Now inner model means these, on these arrows, you can see these values. No, these are like the regression beta coefficients. If you run normal SPSS, you can see the beta values. This is like the beta values, path coefficients. These are relevant to your hypothesis. If you are having maybe directional hypothesis, you can interpret the plus or minus relationship. Sometimes you can have maybe one-sided, two-sided test. Depending on that, you can decide. These are the path coefficients. Now you can see here, reputation positively affect loyalty. No, you can see here, it's 0.8. That's the impact factor. That means when you change reputation by 1 unit, loyalty will be increased by 0.8. That is how you interpret normal beta interpretation, right, in regression. Predictive power. But when you run the normal model, within this circle, now you are having what? This is R squared, right? This R squared. When you normally run, you get the R squared. This R squared. But remember, you want to test it statistically by looking at the t value or the p value to test the hypothesis. Then I again run another algorithm, right? That is calculate consistent algorithm, not the algorithm. Now bootstrapping I run, right? Earlier I ran consistent PLS algorithm to get the path coefficients and the factor loadings. Now I run PLS bootstrapping. Remember, bootstrapping is to look at significance level. Now you are trying to generalize the model to a larger population, which is unknown to you. That's how you need bootstrapping. But before I run bootstrapping, again, I check whether I ran the final model. Consistent. Remember, when you run the final model, you have to change this factor into path. But when you test the outer model, you have to select factor. You are not interested in the inner model, since you are still developing the model, improving the model. But in your final reporting for the path analysis, inner model, you have to select here path. Now you are interested in the path, beta values, path coefficients. Start. I just forgot to tell you that. Right. Path base, you can see some differences. Again, I got to calculate. Now I run consistent PLS algorithm. Bootstrapping. Bootstrapping. You have to go to bootstrapping here. Now, the beauty of Smart PLS is that it generates subsamples from your small data set. Since you don't have normality, sometimes you use PLS. Even if you are having normality, you can use PLS. But in the cases where you don't have normality, still you can use PLS. That's the advantage. You generate subsamples. Remember, in your final analysis, you have to make this 5,000. That's a no. That means from your small data set, they create 5,000 subsamples and they observe the path and they give the final results. It's like something like simulation like, right? From your data set, they create 5,000 subsample and they do the observation and give you the particular results, which can be used to generalize, test the hypothesis, significance, p-value, and also t-value, whether to reject the null hypothesis or not, something like that. If you want, you can change here. By default, it's 95% confidence level. That means significance level 0.05, right? We look at. If you want, you can have one tail with the directional hypothesis or not. By default, two tail. You are not interested in the direction, right? Here you can put the complete one in the final analysis. Make this 5,000. Here no change. It's a path. No weighting factor, no vector here. But for the moment, I will keep this 500 since it takes time. When you're having 5,000, it takes sometimes more than 1 minute to run the model, right? This is happening online, running the algorithm. Therefore, always you have to stay connected with the internet. And depending on your processing power of your computer, it takes time, remember. And if you're having so many indicators, variables, it takes more time, technically, right? In the final one, make this 5,000. But for the moment, I will keep this 500, right? For this example only. Start calculation. Now that generate 500 subsamples and observe. They create a distribution by looking at these 500 subsamples. With the replacement, they create that, right? They take a set and they replace, right? Always with the replacement. You can see it takes some time. Right. Now go to the graph first. Again, you can see the reports also. I go to the graph. Now you see here, very nice thing, no? You see path value within bracket, you see what? Can you tell me what is this? It's a p-value or t-value?
P-value.
P, yes, p-value. But if you want, you can get the p-value also. Look at here. Left side, you can see here in our model. If you want, you can have only the p-values. You are having these options. If you want, you can have only, you can have path coefficients and t-values. Now look at t-value. Normally t-value should be above 1.96. Then only you can reject the null and accept your alternative hypothesis. That means p-value is less than 0.05. Usually we report path value is, path coefficients with p-values, right? Usually we report that. You get for factor loadings also significance level, but we are not concerned about that. But all are significant here. But you can see this factor value is not significant, no? Okay, significant level is above 0.05. Therefore, you could have deleted this one. You can remember in my previous exercise, I deleted finance 2. That had very poor loading. That means which is insignificant also in terms of p-value. Now I am concerned about the inner model, right? I have tested outer model and also model quality here, SR, MR and everything. Now you can see here. Now I test the relationships. Now I have to look at my hypothesis in the model. Brand reputation significantly influences customer loyalty. That's my first hypothesis. Now you can test your hypothesis usual way. There is a relationship which is positive as well, right? And which is significant. Why? P-value is less than 0.05. You can reject null hypothesis saying no relationship. Instead, you can accept alternative saying that there is a positive relationship between reputation and loyalty, or reputation influences loyalty. That's the first hypothesis, testing. Then you have to report that in your data analysis chapter. Then this one also you can see. Reputation affect satisfaction. Satisfaction affect loyalty. You can see that one. Then moderation. Moderation, you have to interpret this new variable, right? If you interpret pricing, that is not the moderation. That is another independent variable affecting satisfaction. If you're having hypothesis, you can test that also. But my main moderation concern is about this variable and the relationship. Now you can see here, price moderate this one or not. Now how can we interpret this one? Now I am having the moderating effect. Now I had a hypothesis about price. Pricing significantly moderate the relationship between customer satisfaction and loyalty. What about the interpretation of this moderation? This is very important. Many people are not interpreting the moderation. They say that there's a moderation. Sometimes direction you can explain. And also you can explain when the price increase or decrease, how this relationship is strengthened or weakened. Now by looking at this one, how can you explain this one? How to interpret the moderation? You see path value minus or positive here. So minus or positive?
Minus.
Okay. Significant or insignificant? By looking at the within bracket p value?
Significant.
Okay, right. There is a negative moderation of pricing on the relationship between reputation and satisfaction. You can write one sentence like that. Further, you have to explain how. Tell me whether pricing weaken or strengthen the link between reputation and satisfaction. As an interpreter, as a manager, this definition is very important. In your thesis, implications can be there sometimes for the decision makers.
It doesn't increase satisfaction.
Okay, if you can bit explain, weaken or strengthen.
It weakens.
Very good. Price weaken the relationship between reputation and satisfaction here. It not necessarily have to be a variable affecting satisfaction, though it's there in this hypothesized model. Mainly you have to look at this moderating effect, interaction effect. Price is having a effect which is negative, that weaken the association between reputation and satisfaction, right? When the pricing effect is there, this relationship is weakened. That's the interpretation of moderation. Sometimes you can look at based on the industry or the particular context, you can try to interpret that practically how it happens. This is based on your sample data set.
But how do you interpret the direct relationship?
Direct.
Yeah.
Which direct relationship?
The between price and satisfaction.
Yes. Then this one you had to look at simply. That's the pricing directly going to satisfaction, or that's a direct relationship. Price is having a negative impact on the satisfaction. Do you see that there? Minus 0.363. That is also significant. Can you see that one?
I didn't see the minus part, sorry. Yeah, okay.
Minus. That means price is having a minus impact on the satisfaction. Higher the price or some particular thing in the price you measure that quality, customer satisfaction diminishes. And further, this relationship also weakened by pricing. When they are happening together, reputation with pricing happening together in a particular context, they weaken that's impact on the satisfaction, cumulative impact on the satisfaction. That's the idea. Moderation effect. Any clarification up to that point? Moderation. I think next week we can discuss mediation, right? I will explain Baron and Kenny's approach. If you have a time, read on the internet, Google Scholar, Baron and Kenny's approach. There are 4 steps to test the mediation. Using that, you can interpret this one. In addition, there is another one, total and the indirect effect, direct and the indirect effect. That approach. Total effect equal, direct and indirect effect. There are two approaches for the mediation. Next day, I will discuss that one also at the beginning. Now, today, mainly we repeated some of the things which we discussed again last time. In addition, I mentioned how to test one construct also separately. Look at its validity and reliability. Then I talk about overall model, outer model also as a holistic model. Look at validity, reliability. We discussed discriminant validity, convergence validity, reliability. Then we talk about model quality indicators like inner model especially, right? That was about SR, MR, FP squared, QV squared, R squared. We discuss. Then main part is about path relationship in your model, testing hypothesis. Here you see how to test the hypothesis. Here there's a mediation also, but next week I will explain mediation, right? Then for the moment, you try to understand how to look at the particular path and the significance level. Moderation also I explained today how to create the moderation. It is not necessary to have moderating variable relationship with the independent variable, but that can have an effect on dependent variable, but not necessarily to have an impact on the independent variable, right? That's why there is no need to arrow from this pricing to reputation, right? If there's an arrow, in that case, again, mediation might be happening. Then it's not a moderator, rational, statistical. That's why arrow can be directed towards dependent variable. And Mr. Lasant asked that question. I think you got answer for that one, Mr. Lasant.
Yes, yes, thank you.
Then you can try this one and ask any clarification. Next time I will discuss in addition to this, this mediation, tetrad analysis, whether to have reflective or formative when there is no literature to support. Further, I will discuss group analysis next week, right? Multi-group analysis, very famous method. You can look at two groups. Now, let's say in my sample, male and female are there. I have a question also. I have identified male and female, giving 1 or 2. Then I can test two models. For the female, what's the relationship in the model? For the male, what's the relationship? Whether relationship is strong with female or male. We can do a nice comparative group analysis, right? That's a group analysis we call multi-group analysis. Next time, I think we can discuss those things. In addition, we will discuss another thing we call something relevant to latent variable scores, right? That is also important for one advanced analysis in the future. Maybe not now. Sometimes you can link this to R software, right? R for advanced analysis. Now there's a tendency for people to develop R-based platform supporting this PLS for advanced analysis, right? Therefore, next time I will show you what are the what do you call latent variable scores, right? And how to analyze some advanced higher order models. Today also we discuss higher order models, right? Reputation is a higher order model. That's a second order one. Reputation is formed by 5 dimensions, right? 5 dimensions. We use the reflective, what you call repeated indicator approach, right? Repeated indicator approach is a reflective model. You can see that one. I think we had about 2 hours for the newcomers. Some people, they can again try this, right? Maybe the first time some people do this, therefore try this. Then you can be a master of PLS, right? With the time. Then for the day, I will conclude, and this recording also I will email Professor Devasiri. He will email you. Then thank you very much. Unless you have any clarification, we can wind up for the day. Next week, not the Wednesday, we have Thursday, remember, right? Next week, we are having 28th Thursday, not the Wednesday, remember. I will send you the link also. Thank you very much. If you don't have any clarification, we can wind up.
Thank you very much.
Thank you very much. Okay.
Sir, am I audible?
Yes.
Okay, thank you, sir. So it is really a great honor for me to deliver the vote of thanks on behalf of the AHEAD Grants, Department of Accountancy and Finance, Sabaragama University of Sri Lanka. I would like to offer my sincere gratitude to Professor G.D. Samarasinghe, Department of Industrial Management, Faculty of Business, University of Mauritania, for sparing his valuable time from the busiest schedule to grace this event. Thank you so much, sir. The session was really very meaningful and interesting. And also, I would like to thank Professor D.G. Dharmaratna, Head Department of Accountancy and Finance, Sabarkama University of Sri Lanka. Then, I'd like to thank Senior Lecturer Mr. Malik Amar Singha, Project Coordinator, AHEAD Grants, Professor Jayantha Devasiri, Deputy Coordinator, AHEAD Grants, and all the academic staff for their dedication on making this event a success. Finally, I would like to thank all the participants for here being with us, and also thank you again all. So sit and have a good night. Thank you.